Hi guys, in this video we are going to discuss the problem D, different arrays, that is from Educational Codeforces around 141, and the problem states that you are given an array A of n integers. You have to perform the sequences of n minus 2 operations on this array. So in a single operations we will either add A2 to A1 and subtract A2 from A3, or we'll do the reverse of that. Then in operation A2 we can add A3 to A2 and subtract A3 from A4, or the opposite of that, so on and so forth till the n minus second element. So after performing these equations, we'll definitely be getting a certain array. We have to report the number of possible arrays that we can obtain by performing these operations. So that was the question says. One thing to observe over here is that the modulus is not the standard 1e9 plus 7 that we generally expect in such questions, and that was the reason I was getting a wrong answer. I kind of detected it later on. So yeah, that's a different value over here. You can see also the constraints over here are that the number n, that is the number of integers in the array, is less than or equal to 300, and each of the elements or each of the those numbers would be less than or equal to 300 and would be greater than or equal to 0. So the constraints are fine. Now how do we proceed this question? So what we can generally say is, let me turn on this up, give me a second. Yeah, so what we can say is that, let's say this is my array, this is a0, this is a1, this is a2, this is a3, a4, a5. So what they're saying is that a1 can either be added to this and added to this. In case we add it to this, then we have to subtract it from here. In case we subtract it from here, then we have to add it here. Then we'll do the same with a2, same with a3, a4, a5 as well. So at the end we'll be getting a number of arrays, right? So we have to report the number of arrays per se. So a very easy way of doing it is recursion. So we can use a recursive function and then provide it with two values. So one values could be the current value of the element. So I'll start with a1 itself, because a0 on a0 this operation cannot be performed. So I'll be starting at a1, and I'll have two choices, right? I can either add this value to like a0, or I can subtract this value from, or I can add this value to a2. So these are the two operations. Since a0 has already been passed, so that doesn't matter to me. I want to look to the right side, right? So what I can say is that a1 can, now a2 can either be a1 plus a2, or a2 can be a2 minus a1. These are the two values which a2 can have. Also, this a1 that you are currently seeing won't be the initial value. For a1 definitely it's going to be an initial value. Let's choose another number. For, let's say, for a4, you might think that the possible values are a4 plus a3, or a4 is equal to a4 minus a3. However, the problem with this is that a3 might itself change because of a2, because a2 is also going to do some like operations on a3. Because of that, the value of a3 could have like changed itself. So this might not hold true. So what we can give the recursive function is that the current value. Let's start with the index first. So I can give the index which I'm checking for. I'll start it by 1 itself, because as discussed, 0 is not available for any operations. So I'll start with index as 1. Then I can give it the entire array. I'll definitely require it for some other operation, so I'll give it the entire array as well. Other than that, I'll give it the value of the current variable which I'm standing at. So right now I'm standing at a1, and the value also would be a1 itself, because at a1 no operation is performed. By no operation is performed is that the value of a1 is unchanged, right? Initially, because a0 doesn't perform any operation, and because of that, initially value of a1 would be a1 itself. Then in this, what I can do is that if, so let's say there are two cases, that if my value of a1 is 0, then it won't matter, right? Then it won't matter that I'm adding to a2, or I'm subtracting to a2. So that case won't matter. If it's anything other than a1, then a subtraction or addition would actually matter. So if it's a1, so subtraction or addition would actually mean the same. So I can simply return recursion of idx plus 1. So I'll be going to the next index. The rest would be the rest itself. So this is basically the vec. Let's call it vec, so as to keep a standard nomenclature. And then over here we have the values. So the values would be rest of index plus 1. You can actually do plus a1 over here, but that won't actually matter, right? And let's give a generic name to a1 itself, so let's call it current. So let's call it current. If current is 0, we can actually add current over here, but anything, if we add 0 to anything, it still remains the same, so that actually doesn't matter. Else what we'll say is that we have to return recursion of idx plus 1 vec is idx plus 1 plus current. Also the rest of the things will remain same, but over here, rather than adding it, we can subtract it. That's it. So this is the entire logic. Now the problem is that we'll be computing over the same values again and again. So what we'll do is that we'll maintain a cache, or as DP you might call it. So in the DP we'll be giving two values. So first one would be the IDX, second would be the current value. If we have already seen this, then we can directly return it. Also the terminating condition over here would be if my IDX or the index I'm checking at is equal to the vec dot size minus 1, because once I'm at the last element, I can't perform any operations at the last element itself. So standing at a5, I can't perform any operations, that we definitely know. So if this condition happens, then I can return 1, because this is some array that I can generate now. Yeah, as simple as that. One more thing, however, to note over here is that since I'm coding in C++, so I'll have to check for this condition. If you are coding in, let's say, Python or any other language which actually supports storing negative values into integers, then it's fine. But since CPP doesn't, not storing but rather like accessing negative values, so CPP doesn't allow me accessing negative indexes. So over here I'll have to add something to it. Now what can I add? So if we remember that the number of integers, they were less than or equal to 300. Also value of each integers could be was less than 300 itself. So even in the worst case, if I'm like if I keep on subtracting all the values, even in that case, my final value, like the most negative value I can get is minus 300 into 300, that's 9e4. So this is the value I'll be adding. Yeah, that's it. I think I didn't like explain it too much because it was pretty simple. Let's look at the code now. Maybe then it would make more sense to you. So that this is the code. So this small thing is the code. You can actually even make it more smaller, but this was more intuitive to me. So initially I'm taking the vector that actually is required. Once I've taken the vector, I've actually defined a DP. So this over here in the ith location, the index would come. Indexes are up to 300, so that's why I'm taking it. Then I'm using 18, like it's 18e4, so 18,000, right? So 18,000, the reason I'm taking 18,000 is that I have to cover values from minus 9e4 to plus 9e4 as discussed. So 18,000 actually can do that. Once inside the loop, what I'm saying is if I'm standing at the last element, then I can simply return 1. Else, if the value was already calculated for this index and for this current value, then I'm going to return that, so that I don't do the repetitive computations again and again. Else, so this over here I'm taking the value that I'll get if I add cur to it, right? Now why I'm not subtracting cur to it, because as I discussed that what if the value of cur or the current element is 0, then subtraction and addition would have the similar effect and we don't need to perform both of them, otherwise there would be duplicacy in the data. So I'll only be performing a subtraction if cur is not equal to 0 or the current value is not 0. If it's not 0, I'm performing the subtraction and I'm adding the value to my result. After that I'll be taking a mod. So this is somewhere I actually messed up, so always remember to take the mod as they had defined. This is the value of the mode they had defined in the question. So I'll be taking that mod, I'll be storing it in my answer or in my DP, and I'll be returning it, and then I'll simply be printing it. So let's copy paste this and let's try to run this up. Yep, this works. So yeah, that's it about this question. I must say, like, this problem was really easy, but I even didn't look at this problem in in the contest, because till the end time I was actually stuck with C because of another silly mistake. So yeah, I'll say like if you're able to do ABC, definitely check out D. Sometimes it's pretty easy like this one. So you might be able to do D as well, and then your rating would definitely boost up. Other than that, if you check for the topper solutions, so they actually have used bottom-up DP. Now bottom-up DP is less intuitive. That's the only reason I didn't explain that. So okay, so that's a big template. So yeah, over here you can see that they have actually used bottom-up DP. Now bottom-up DP is not that intuitive and it requires some experience, but the top-down DP is somewhat that makes more sense to me as and is more intuitive. Though bottom up is better in terms of time and space complexity, but anything that passes the test cases of over here is good enough for us to work with, right? So yeah, that's it. If you have any questions, let me know. I'll be more than happy to answer them.